Okay, hi everyone. We didn't get to some important things in our lesson, so I'm going to try and make this short, but this is important. I'm going to quickly go over what casework is in math counts. So what is casework? Casework is a strategy that breaks down hard problems into smaller bits, which makes it easier to solve. Most of you have probably already used casework before. Casework helps you stay organized, especially when you're counting things. Not just counting in problems, in everyday life. If you're counting things and you put things to one side to save them for later, that's pretty similar to what casework is in math counts. So the best way to illustrate casework is to look at an example problem. So example 1, how many triangles are in this picture? And I'm not just talking about these small triangles. I'm also talking about like the larger triangles within the picture. So to do this problem, we want to try to keep organized because there's a lot of triangles. And we can do this by counting different types of triangles. So first, we can count how many of these single triangles there are. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of them. Now, if you have a piece of paper and you're doing this along, just like draw like a single triangle and write the number 16 next to it, because that's a good way to keep track of it. Okay, next we can count another type of triangle. This is a larger triangle, but it's still a triangle. And when it's asking about how many triangles are in this picture, it also refers to these other triangles too. And you can count how many there are. There's 1, 2, 3, 4, 5, 6. And then there's actually an upside down one in the middle. So that would be 7. So again, if you are doing this in a real competition, you might want to draw a quick picture of this triangle on your paper and write 7 next to it so you could keep track. And then you just continue counting up until you reach the biggest triangle, which would just be the entire image. And then, like, let's just, if you're watching this video, pause and see if you can continue counting the triangles and then see what you get. Okay, I'm going to move on now. Okay, so you should have counted 16 of these small triangles, 7 of these like these larger triangles, which are made of 4 smaller ones. And you should have counted 3 of these larger triangles, which are made of 9 of these smaller ones. And finally, you should have counted 1 big triangle, which is the whole image. So in total, you should have gotten 16 plus 7 plus 3 plus 1, which is 27 triangles. So yeah, that's basically what casework is. It's just staying organized in your work, making categories as you're counting, and in this problem, we counted the different types of triangles first, and then added the numbers together at the end. The different types of triangles can be called cases, which is why it's called casework, because you're splitting the problem into cases and looking at each one individually first, and then you can add them all up together. And an alternate strategy, if you didn't use casework, you'd probably just randomly counting triangles and then probably like doing tally marks on your paper as you went along. But that's a bad idea because you could accidentally count a triangle more than once, or you could forget to count a triangle. Casework helps with that by making it easier for you to keep track of things. And that's basically what casework is. Casework is more of a math strategy, not so much math formulas or numbers. It's just more of a way of thinking and a way of solving problems. But this is still pretty important because math counts likes to throw a lot of these casework problems at you. So for example, this problem. This one is not a geometry problem like the last one. How many 3-digit numbers have digits that add up to 7? There really is no formula to solve this. You just have to list them out one by one. If you're watching the video, pause and see if you can list out all the numbers. Okay, so again, it's not a good idea to list out random numbers. Instead, let's use a casework strategy. First, let's pretend that the first digit has to be 7, because that's the maximum possible digit it could be. If the first digit's 7, then let's list out all the possible values all the possible solutions if the first digit is 7. In that case, we can only have 700 or 700. That's one case. Next, we say, let's make the first digit 6 now. And let's list out all the solutions for if the first digit is 6. In that case, we could have 601 and 610. And that's all. So there would be 2 cases for that. Next, we're going to say if the first digit is 5. Then we list out the solutions. We could have 520, 502, and 511. There are 3 cases. And then we can say if the first digit is 4, etc. We list them out. We find 4 cases. And by now, I mean, I guess you could continue listing them all the way until 1. But if you're staying organized and you're maybe making a table on your paper and looking at the numbers you've gotten, you may notice a pattern. The first case, if the first digit is 7, there's 1 case. The first digit is 6, there's 2 cases. If the first digit is 5, then there's 3 cases, etc. You can see that the number of cases are increasing. So really, we don't need to list out every single possible solution. We just list out a couple, and then we can see, oh, there's a pattern. And then we can just add up all the numbers from 7 to 1, and that will be our answer. So 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 is 28, and that's our answer. So you can see casework makes things easier. It would not be a good idea to randomly list out numbers. It would be better to list them out in order, because then you can see patterns and it just helps you stay organized. And those patterns can save you a lot of work sometimes. However, you still do need to be careful because some patterns can sometimes be a little misleading. Okay, here's another example. How many ways are there to make 15 cents if you have 1 dime, 2 nickels, and 10 pennies? Again, if you're watching the video, you can pause, try to work this out by yourself. Okay, so again, we can use a casework strategy. First, let's just say we have to use the dime when we're making the 15 cents. So in that case, we could list out, we could have 1 dime, 1 nickel, and 0 pennies. Or we could have 1 dime, 0 nickels, and 5 pennies. Now, let's say we can't use the dime because in this problem, you either use the dime when making 15 cents or you don't use the dime when making 15 cents. By splitting the problem into 2 separate parts, it's easier to solve. So anyway, picking up where we left off. If we cannot use our dime to make 15 cents, then we could use 2 nickels and 5 pennies to make 15 cents, or we could use 1 nickel and 10 pennies to make 15 cents. So in total, we have 4 ways to make 15 cents. And that's our answer. So once again, casework has made this problem easier by breaking it down into smaller parts, and it helps you stay organized. Okay, here are some more casework problems. Most of these will be visual problems. For example, here, how many different squares can you make by connecting 4 dots on this grid? And again, pause the video if you're trying to solve this. Okay, here's the solution. So first, well, we're going to have to list out the types of squares. And if you're in a real paper test, it would be you would have to draw on their diagram, probably trace out the dots and trace out the squares and then erase it and trace out some more. Here, I'm just going to show you the types of squares. First, we have these single squares, which if we go back, we can see there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 of those. And next, we have these squares, which are like 2 by 2 squares. And if you go back to the previous slide and count, there will be 4 of them. And then finally, we have the biggest square, which we have 1 of those. However, that's actually not all the squares there are, because you can actually have tilted squares. See, like this one. These squares are tilted, but they're still squares, and we have 4 of those. And even then, we have another tilted square. This one is even trickier to find, and we have 2 of these. So in total, we'll have 9 plus 4 plus 1 plus 4 plus 2, which equals 20 different squares. So for this problem, you just have to be careful. You need to sort of think outside of the box in these problems because it's very easy to miss something on accident. Okay, here's another problem. How many 3-digit numbers have their digits summed to 11? And again, if you want to, you may want to list these out on a table. That would help. Okay, here's the solution. So here's my table. The answer is 61 if you got that. If you didn't, that's all right because this question is a little different than the other ones. Let's first say that the first digit is 9. In that case, we could have 920, 902, 911, which that's 3 different solutions. For the second case, if the digit is 8, we'll have 4 solutions: 830, 803, 821, and 812. And then we go so on and so forth until we reach we go all the way down. However, there's an issue with this problem is that the pattern, like you may notice a pattern, it goes 3, 4, 5, etc. all the way, and then but it doesn't continue that way. If the first digit is 2, we will have 10 solutions, which are listed out here. But if the digit is 1, we only have 9 solutions, not 11. Why not? Well, if you notice the way the solutions are listed out, you can see that in the solution for 2, we have this number 290. If that 2 became a 1, we would only have 11 solutions if the number 10 was a digit. But like if you list them out, the only way there could be 11 solutions is if there was a number 1, 0, 10, but 10 is not a digit. So you can't have that, which is why there's only 9 solutions for this last one, and it might throw some people off. And altogether, we have 61 solutions. So casework would definitely make this problem easier, but you need to be careful about it. A good strategy would be to list out the first couple of solutions and notice a pattern, and list out the last couple of solutions just to make sure the pattern stays throughout the whole problem. Otherwise, you might have this situation where you're just off by a couple of numbers because the pattern just broke at the last minute. Okay, how many rectangles or squares are in this figure? Okay, here's the solution. This one is a little harder. This one may take you a little bit of time to do. And I don't expect all of you to get this particular problem right because this one is a little more tricky. But it's just to introduce you to some of the harder things you might see. On the quiz, you will have some simpler casework problems as well as some harder ones, just to give you a mix to show you, to expose you to both types. For this one, again, you'll have to, it would be better to do it on a paper test than an online test. It would be a good idea to make a table and list them out and trace the rectangles as you counted them so you wouldn't miss any. So yeah, you would just have to make a table and then you can add them up and get the answer of 44. And again, this would be a lot harder without casework, but some casework problems can still be hard. It's just casework makes it a little easier for you to solve them. Yeah, and here are some of the ones you may have missed if you try to do this problem. Okay, now this one is a cool problem. I like this one. How many triangles are in this figure? And again, pause the video, try to work it out by yourself. Okay, here's the solution. So first we have 12 of these little triangles. That should be pretty easy. And then we have 6 of these like quad triangles. And this is pretty cool because it might look a little confusing at first to count these, but you should notice that the triangles, they have to be sort of like poking out the side, because this is basically a 6-sided or 6-pointed star. And in order for these triangles to fit, one of the small triangles has to be in that corner. And since there's 6 corners, there's going to be 6 of those. So there's going to be 1, 2, 3, 4, 5, and 6. And finally, you have these larger 9 triangles. And there's only 2 of these because this one has, in order for this to fit in the diagram, it has to go through 3 of the corners, like this and like this. So in total, there'd be 12 plus 6 plus 2, which equals 20 triangles. And finally, this one is a little bit easier than the previous one. How many parallelograms are in this figure? Okay, here's the solution. So there are 4 single parallelograms. And what I mean is that there's like one here, one here, one here, and one here. And then there are 4 double parallelograms. And what I mean is that there's like one here, there's one here, there's also one here, and there's also one here. And finally, there's one big parallelogram, which is just this whole diagram. And so that would be a total of 4 plus 4 plus 1, which equals 9 parallelograms. And that's it for this casework lesson. This should be more of a brief video. Casework, again, just to summarize, casework is not so much about the formulas and the numbers. It's more about a way of solving problems. And a lot of casework problems involve these geometric type problems, or counting the number of rectangles, or you're counting the number of triangles, or the number of paths. This is what casework is more like, and you'll see a couple of those on your quiz. Hopefully you should be able to solve the simpler ones. The last casework problem is a little hard. Number 10, it will be a more difficult casework problem. If you want to try it, you can. And if you think it would be easier for you to work it out by hand, you can always print out the quiz page and then use the diagrams there. So I personally like casework problems because they're not so much math. They're just more about like counting and thinking outside the box. So hopefully this video will help you on your quiz.